Hello viewers and welcome to our channel. Today, we're diving into the world of blockchain. What is it and why is everyone talking about it? So without further ado, let's dive into the video and subscribe to the channel. Blockchain, an innovative and transformative technology, has revolutionized the way data is stored and managed. It functions as a distributed ledger system that is highly secure and virtually tamper-proof. By design, blockchain ensures the integrity and immutability of data, making it practically impossible to hack or alter information stored within the network. At its core, blockchain operates as a decentralized, distributed database, setting it apart from traditional centralized databases. The data in a blockchain is structured in blocks that are linked together through cryptographic hashes, forming a continuous chain. Each block contains a set of transactions, and every computer within the blockchain network maintains a copy of this ledger. This decentralized structure prevents a single point of failure and enhances the security and resilience of the system. Initially popularized by Bitcoin in 2009, blockchain technology has evolved far beyond its cryptocurrency origins. While Bitcoin and other digital currencies leverage public ledgers, various industries and sectors have recognized the potential of private ledger blockchains for applications beyond finance. These applications include supply chain management, intellectual property protection, smart contracts, and even experiments in central bank-backed digital currencies. One of the primary reasons for the growing adoption of blockchain is its ability to create and maintain a secure, shared database among multiple parties. This decentralized nature, coupled with its immutability and security features, has made blockchain a preferred choice for secure data sharing and transparent record-keeping across diverse business entities. The key characteristics that define blockchain technology are pivotal in understanding its widespread application. Decentralization. Blockchain operates on a network of nodes, with each node maintaining a copy of the entire ledger. This decentralized structure ensures transparency and resilience, eliminating the dependence on a central authority. Immutability and security. Cryptographic techniques are used to secure data within blocks, making it extremely difficult to alter the information. This immutability ensures the integrity and security of the stored data. Transparency and traceability. Every transaction recorded on the blockchain is visible to all participants, enhancing trust and accountability within the network. Additionally, the ability to trace the history of assets is a crucial feature for auditing and fraud prevention. Smart contracts. Smart contracts are self-executing contracts with terms directly written into code. They automate the execution of agreements and eliminate the need for intermediaries, thereby streamlining processes and reducing costs. The process of blockchain technology involves multiple steps. Step 1. Transaction initiation and authentication by authorized participants. Step 2. Creation of a block representing the transaction or data. Step 3. Distribution of the block to all network nodes. Step 4. Validation of the transaction by authorized nodes and its addition to the blockchain. Step 5. Network-wide distribution to finalize the transaction. Nodes in public blockchain networks, often referred to as miners, play a crucial role in validating transactions, often receiving rewards, typically in the form of cryptocurrency, for their efforts. It's important to note the distinction between blockchain, digital currency, cryptocurrency, and Bitcoin. Blockchain is the foundational technology that enables the existence of digital currencies and cryptocurrencies. Digital currency refers to any form of currency in digital or electronic form, including government-issued digital money and cryptocurrencies. Cryptocurrency specifically denotes digital assets used within blockchain networks and isn't government-issued. Bitcoin is the pioneering and most recognized cryptocurrency that operates on a decentralized network. Smart contracts, another significant aspect of blockchain, have far-reaching implications across various sectors. These self-executing digital contracts facilitate and enforce agreements without intermediaries, leading to reduced costs, faster transactions, and heightened security. As blockchain technology continues to evolve, its impact extends beyond financial applications. Industries such as logistics, healthcare, real estate, and entertainment are exploring and implementing blockchain-based solutions. The secure, transparent, and efficient nature of blockchain offers opportunities to streamline processes and enhance security in an array of operations. The fundamental principles and unique features of blockchain technology position it as a disruptive force, reshaping how data is managed and transactions are conducted across multiple industries. Its impact is continually expanding, propelling innovation and reshaping business practices in an increasingly digitized world. Blockchain, originally renowned for its association with cryptocurrencies, has significantly evolved, expanding its application to various industries, spawning innovative use cases that transcend the realm of financial transactions. Industries across the spectrum have recognized the potential of blockchain technology in revolutionizing conventional practices. Its use cases span from supply chain management, healthcare, identity management, voting systems, finance and banking, media, and entertainment to emerging trends like NFTs, non-fungible tokens. Examples and applications: supply chain management. Blockchain's end-to-end visibility and accountability make it an invaluable asset in managing supply chains. Its ability to record, track, and authenticate products aids in preventing counterfeit goods from infiltrating the supply chain, ultimately streamlining logistics processes. Healthcare. In the healthcare sector, blockchain, in conjunction with artificial intelligence and IoT, securely stores and shares patient data. Patients can control their medical records, granting access to healthcare providers as necessary. This fosters seamless, secure sharing of medical information, enhancing treatment outcomes and reducing administrative burdens. Identity management. Blockchain-based identity management systems improve security and privacy, offering users a portable and verifiable digital identity. This significantly reduces identity theft and simplifies identity verification processes by consolidating identity information on the blockchain. Voting systems. Blockchain technology presents a potential solution to the challenges of traditional voting systems by providing secure and transparent platforms. These systems can eliminate voter fraud, ensure the integrity of the electoral process, and enable remote voting while maintaining anonymity and privacy. Finance and banking. Financial services exploit blockchain to expedite transactions and enhance operational efficiency. Blockchain is employed in contract management and traceability purposes within some banks. Notably, platforms like PayPal have launched blockchain-based services, allowing users to buy, hold, and sell cryptocurrency. Media and entertainment. Blockchain technology broadens revenue opportunities in the media and entertainment industry. Organizations leverage blockchain to create digital assets, enabling them to collect royalties when assets are resold. The use of blockchain in entertainment has seen companies like Live Nation SAS deploying blockchain-powered solutions. Advantages and disadvantages. Advantages of blockchain. Uncorruptible. The decentralized nature of blockchain makes corruption almost impossible, as millions of computers share and reconcile information without a single point of failure. Efficiency. Transactions are generally more efficient than non-DLT-based systems, despite public blockchains occasionally facing speed and efficiency issues. Resilience. If one node fails, other nodes have copies of the ledger, ensuring continued functionality. Trustworthiness. The difficulty of reversing confirmed blocks ensures data integrity and security. Cost-effectiveness. Eliminating intermediaries and third parties often reduces transaction expenses, making it a cost-effective option. Disadvantages of blockchain. Ownership concerns. Questions regarding ownership and liability arise in case of problems. Infrastructure challenges. Implementing and maintaining a blockchain network requires substantial investments. Data management. Modifying data within a blockchain involves significant effort. Private keys. Users must secure private keys to avoid financial losses. Storage issues. The exponential growth of data could risk node accessibility if the ledger becomes overly large. Vulnerabilities. Blockchain is vulnerable to 51% attacks designed to overwhelm the network and alter blocks. Types of blockchain. Blockchain can be categorized into 4 main types. Number 1. Private blockchain. requires approval to access, offering enhanced privacy and control, suitable for applications necessitating strict access control. Number 2. Public blockchain. Doesn't require permission to enter the network, enabling every node in the network to conduct transactions and participate in consensus. Number 3. Hybrid blockchain. Combines aspects of both private and public blockchains, providing organizations access control over sensitive data. Number 4. Consortium blockchain. Governed by a group of organizations, combining decentralization and privacy, ideal for collaboration among a select group of participants. Leading blockchain platforms. Several prominent blockchain platforms are widely utilized. Ethereum. Ethereum stands as one of the most influential and widely adopted open-source blockchain platforms. It introduced smart contracts and decentralized applications, dApps, transforming the landscape of blockchain technology. Founded by Vitalik Buterin in 2015, Ethereum's revolutionary approach to blockchain technology opened up a new realm of possibilities beyond mere financial transactions. Smart contracts and decentralized applications. Smart contracts, a hallmark feature of Ethereum, are self-executing contracts with terms directly coded into the platform. They automatically execute actions when predefined conditions are met, without the need for intermediaries, facilitating trust and security in transactions. These contracts have broad-ranging applications, from automated financial agreements to governance mechanisms in decentralized organizations. Ether, Ethereum's native cryptocurrency. Ether, ETH, is Ethereum's native cryptocurrency, functioning as a digital asset used to fuel operations within the Ethereum network. Beyond its use as a form of digital currency, Ether plays a pivotal role in powering transactions, executing smart contracts, and incentivizing network participants. Hyperledger Fabric. Hyperledger Fabric, developed under the Linux Foundation's Hyperledger umbrella, is a specialized blockchain platform designed for permissioned networks. It presents a modular and highly flexible framework, making it an ideal choice for constructing tailored private blockchains to cater to specific business needs. Permissioned networks and tailored solutions. Hyperledger Fabric prioritizes privacy and offers a high degree of control over data access. It allows organizations to design customized blockchains with fine-grained permissions, ensuring stringent access controls and compliance with regulatory requirements. Enterprises and businesses find Hyperledger Fabric particularly appealing due to its capability to meet specific industry demands by offering enhanced security and privacy features. Modular architecture. The modular architecture of Hyperledger Fabric provides the flexibility to selectively incorporate components that suit a particular use case. This modularity allows for the integration of diverse consensus algorithms, smart contract engines, and identity solutions, ensuring tailored blockchain implementations that address various business complexities. OpenChain. OpenChain is a purpose-built blockchain platform primarily focused on managing and preserving digital assets. It offers a specialized approach to ledger rules, allowing administrators to define specific guidelines for value exchange within the network. Digital asset management. OpenChain's core functionality revolves around enabling organizations to effectively manage digital assets. It provides a structure for users to issue and manage digital assets, facilitating efficient and secure transactions within a defined network. Customizable ledger rules. One of the key features of OpenChain is the ability for administrators to set ledger rules according to their specific requirements. This customizable rule set governs the exchange of assets, ensuring that transactions adhere to the defined guidelines. Advantages in specific use cases. OpenChain caters to various sectors requiring precise management of digital assets, including finance, supply chain, and other industries reliant on asset tokenization and secure record-keeping. Summarizing the significance, these blockchain platforms, Ethereum, Hyperledger Fabric, and OpenChain, represent diverse approaches and functionalities, each tailored for specific business and industry needs. They showcase the flexibility and potential that blockchain technology offers, spanning from enabling decentralized applications and smart contracts to tailored solutions for managing digital assets in a secure and efficient manner. History of blockchain. The concept of blockchain dates back decades. The modern blockchain model originated with a 2008 white paper by an anonymous figure or group known as Satoshi Nakamoto, which introduced the first blockchain implementation through Bitcoin in 2009. Since then, enterprises have been increasingly exploring blockchain's potential, leading to various applications and trends such as DeFi and the rise of NFTs. Thanks for watching. Don't forget to like, share, and subscribe for more insightful content. Until next time.